A lot of people think engineers just know the answer. They do not. A lot of the time they're looking at a problem and that they have not solved before. They do not know exactly what is wrong yet. They do not know exactly what part is failing yet. They do not know exactly what the best answer is yet. A lot of people think engineers just know the answer. They do not. A lot of the time they're looking at a problem they have not solved before. They do not know exactly what is wrong yet. They do not know exactly what part is failing yet. They do not know exactly what the best answer is yet. What helps is the way they think through it. That is what I want to talk about in this video, because a lot of people freeze when they do not know the answer. They see a hard problem, they feel behind, they feel dumb, they feel the pressure to solve it fast, then their brain starts spinning. That makes everything harder. If you want to think like an engineer when you do not know the answer yet, the first thing to do is to slow down and to define the problem. What is actually happening? What is supposed to happen? What is the gap between those two things? That matters a lot because people jump into fixing mode way too fast. They start trying random stuff before they even say clearly what the problem is. And if the problem is not clear, the fix is usually not random too. I always want to start with the problem statement. What do I see? What do I expect? What is different? That gives me something to work with. After that, I define success. What would a working result actually look like? What does solved mean here? Because if I do not know what success looks like, then I cannot judge whether the next step is to getting closer or not. Then I separate what I know from what I do not know. That is big. What do I actually know for sure? What have I measured? What have I seen? What has already been confirmed? What part is working? What part is failing? What assumptions am I making? That clears up a lot fast, because when people get stressed, they mix facts and guesses together. Once that happens, the whole problem gets muddy. I like to make that split early. Here's what I know, here's what I do not know yet. Then I break down the problem into smaller parts. This helps almost every time. If the whole system feels overwhelming, I stop looking at the whole system at once. I ask, what are the parts? If it is a hardware, maybe I split into power control logic, sensor, input, output wiring, thermal layout, enclosure. If it is software, maybe I split into front end, back end, auth database, API, state payment flow, event handling. If it is a business system, then I split into lead capture, follow-up, handoff, delivery, tracking, communication. Once I can see those parts, I can stop treating the whole thing like one giant wall. Now I can start checking sections. Then I could look for constraints, what limits the system, what has to stay true, what is fixed, what is required, what cannot be ignored, what range do I have to stay inside. Constraints help a lot because they narrow the search. They remove bad options faster. Then I start testing one assumption at a time. This is one of the biggest habits people need. Change one thing. Watch what happens. Learn from that. Do not change 5 things all at once. Then act confused when you do not know what caused that result. That will waste your time fast. And if I'm troubleshooting something, I want to check clean feedback. I want to know what changed and what that did change. That is how you make progress without guessing blindly. Another thing that helps is asking where the failure is most likely to live. What part of the system has the most pressure on it? What part is least understood? What part changed recently? What part connects to the symptom I'm seeing? That helps me focus instead of scattering my attention elsewhere. I also try to keep my emotions from taking over the whole process, because a lot of people make one mistake and suddenly the story in their head becomes, I suck at this, I'm behind, I should already know this. That story does not help. The problem does not care about your shame. The system is doing what it's doing. Your job is to read about it better. That is much more useful mindset. Look at signals, look at the behavior, look at the pattern, look at the failure, look at what changed, work the problem. Do not turn it into an identity crisis. To make this more real, let's say I'm building a hardware device and the screen is not turning on. I do not start by panicking and saying the whole build is broken. I start narrowing. Is power getting to the board? Is the board powered correctly? Is the display wired correctly? Is the code even trying to drive the display? Is the display compatible? Is the connector orientation? Did I test the simplest possible case? Now I'm moving. The same thing in software. Say a payment flow is failing. I do not start with the whole app. I narrow it. Is the checkout starting? Is the payment provider returning success? Is the webhook firing? Is the backend updating the account state? Is the front end reflecting that state? Where exactly is the chain breaking? That is engineering thinking. You work the chain, you do not stare at the whole problem and hope clearly shows up. That is the big reason why engineering is valuable outside of engineering too. It trains you to stay calm under unclear things. It trains you to define problems, separate facts from guesses, breaks complexity into parts, respect constraints, test assumptions, move step by step instead of emotionally. That is useful technical work, business, content, building products, life in general, because a lot of hard situations feel impossible until you define them better. That is usually the shift. Better definition, better breakdown, better testing, better signal. When people ask how to think like an engineer when you do not know the answer yet is really what I mean. Slow down, define the problem, define success, separate what you know from what you do not know. Break it into parts, expect the constraints, test one assumption at a time, watch the signals, keep moving. You do not need to start with certainty. You need a process that helps you find clarity without guessing your way into a bigger mess. That is what engineering thinking is so useful. It gives you a way to move forward before you have the full answer. And that is huge because most real problems do not come with the answer attached.